Hi everybody, and good morning, good afternoon, good evening, wherever you may be. We're going to go straight into the introduction of InterSystems Cloud Manager. And the slideware is going to be covering three main parts. The first one is trying to frame the context within which we are working with InterSystems Cloud Manager. Of course, it's the cloud, but we're going to see some details about that. The second is how the industry and the market at large has been answering this question, has been answering these challenges of how do you work with APIs, how do you become agile. And then the third point will be our answer or answers, because we think we have technology that can provide you with an efficient way to move and to morph your application to a more cloud native, or at least cloud friendly application that that can be leveraged with more efficiency. So what's the context? It's very much the cloud. So we know the cloud is about on-demand resources, rapid elasticity, pulling these resources and also shutting them down very quickly. So it's about being very, very flexible and have lots of agility in provisioning all these resources. And in the last few years, we've seen that this movement, this way of utilizing resources, utilizing these big utilities providers out there, AWS, Azure, and GCP, has become the mantra and the way of operating even on premises. But of course, we've had virtualization for several years, for probably a couple of decades, right, by now. But virtualization, although it was a nice dream and we did a lot with it, it just didn't provide all that elasticity and that on-demand pooling of resources that we actually see we're able to do with the cloud. In other words, cloud it's a lot more. And I went to grab this Gartner blog from 2015 where it identified reasons why private clouds were failing. If you look at the big pie there, the blue part and the one and the gray pie as well, we see that there's probably about 50% of the reasons because there's a failure to change the operational model, the way you work in a more agile way, fundamentally. So what's so cool then about cloud? I think there's two aspects to it. The first one is it's about the abstraction level that the cloud gives us when we talk about our resources that we can provision. And the second one is the operational agility then that cloud actually gives us. We can be very quick, very efficient, and very smart in the way we work with cloud. And so, of course, it's not a specific solution. It's not, the AWS portal that most of us, remember and play with. It's just, a way, an operational way to adapt to a very dynamic, fast, agile, and more efficient way of working with IT resources. But of course, what's happening is, as we look at, especially the public cloud provider, we see that the layer that is very important, that really sticks out, that really speaks to us, is that software-defined, everything really that we have. So we have, there's abstraction when I configure compute nodes and storage and networking, but that's not finished, right? They haven't finished just with I offer you services and you come at the infrastructure as a service layer. There's a lot more up there. I can have a full application, so a full SaaS offering, but there's more. They keep pushing the boundary, and all this is that first point that I mentioned in the previous slide. This level of abstraction that pushes us to think in terms of what we want to build, the application, the solution that we have in mind. And I think that's very powerful. And so of late, in the last couple of years, we've seen cars both spelled with a C, one spelled with a C, the other one with a K, not because they can't spell, but because it's a very clear reference to Kubernetes, that these services, they're just there receiving containers. And this is very powerful again, because it abstracts further away from the operating system. I don't have to think about it. If I'm a business expert, a business domain expert, and I want to sell my particular application, my particular expertise, I'm focusing totally on the application. Why should I ever think about, but I need to tune the Linux kernel? And we probably had to get to that at one point, but the general idea is that the cloud provider take care of everything for us. And that's very powerful. And it's not finished. We can go further, and there's the concept now of serverless. I can just define some function, and the cloud provider runs the function for me. And there are already examples of a fully functional application running in the cloud that leverage this further abstraction, where we don't even talk about containers or unikernel or anything of that nature. You just put your code there, and they run it for you, and they scale it, etc. And I had to put this because it came in my inbox right yesterday from 451 Research, and he said, serverless, container, microservice are making infrastructure invisible, just to confirm that really there's this shift in abstracting away from what really used to be a pain point and still is in some instances. And so here, we understand that by separating the two parts, the user-facing solution, the service portal, some of the management that are offered to us, some of the automation, from the SDDC, from the software-defined data center, the part below the big line there, where everything is a service, we are able to actually we gain a level of portability and choice that's really uncommon, has been uncommon till yesterday. The ability then to leverage cloud providers for what they truly are, utilities, and run workloads whenever and wherever it fits us better. I mean, this is what really cloud operational agility allows us to do if we don't just embrace one single provider. And what we see here, all those logos that we have there, is that this started obviously with the public cloud providers, but there's a very strong movement that we see with the HCI, with the hyper-converged infrastructure technology like Nutanix and Dell EMC that they're offering these days. We see the same type of operational agility that's been brought into the on-premise, the private data center. And this is very good, of course, because it allows us to be very agile. Also, we have to be very careful because the fact that storage is abstracted from us, we need to make sure that the requirement of our application IOPS are satisfied. So we need to be very careful at the same time. But in general, it offers us a lot of agility, a lot of power. So let's just think about the concept of abstraction versus concrete here. So we have an example of a concrete blocks here, and I'm thinking of the boxes when they're delivered in a data center. And when I order some hardware, maybe it takes 3, 4, 5 months. Then eventually they arrive, and then we need to send somebody downstairs to open the boxes, to take the hardware out, to unplug everything, to plug in everything. And although the power plug is probably easy to find and to plug in, then I have Ethernet cable to connect. I might have more than one NICs. I might have, most probably have fiber channel connectivity for the storage area network, and so that's the world of the concrete level of operating, where things takes months, and next month I can have the networking team coming on site and setting everything up, etc., etc. On the other side, I got a pure abstraction, which is just my mind imagining what I really want. And just to put a smile on our faces, this was a concrete implementation of a storage of 5 megabytes more than half a century ago. And it's funny to see how the IT world is really moving fast. But this is an abstract implementation of a typical InterSystems IRIS, sharding architecture. And all I have to do, I have to think about what I want, and I have to design it. And the fact that this is a design that may be hiding from me, a YAML definition, a JSON, XML definition, that doesn't really matter. The point is that I'm defining everything at a really abstract level, and the cloud provider really goes and implement everything. However, the details are very important. So when let's talk about AWS, for example, I need to decide in which region I want my VPC. VPC as a virtual private cloud is a data center. We can think of it as a data center, so an abstract data center. And then it could be seen as a traditional, InterSystem product type of implementation. I've got tiers of web servers, I've got application server, I've got database servers, and I put them into a particular availability zone. I make sure that the IP addresses have their ranges for each tiers, but also I want to have like a failover system. So I'm going to another availability zone, which is like another floor in a data center or another building in the campus of my data center. And so there's a lot of details that come come facing us straight away versus having months to organize a project, to have different teams of people that go and unbox and set up my hardware. And so this proves to be an issue, because we need to be well conversant with all the technology there, from networking to storage, etc. Yeah. And yes, thank you, Michelle. So there's that yellow queue there for questions. There's will be the first poll that is going to be asked of you. So please enjoy answering your question.
So it looks like we have about a quarter of people saying they use AWS, a quarter use Azure, and about half say they do not yet use a public cloud.
Okay. Great. Thank you, Michelle. And of course, when we talk abstract design of our cloud, of our infrastructure, and then we look at InterSystems IRIS data platform that has, multimodal engine, data engine rendering, supports multi-workload, and we have open analytics, interoperability, one of the strengths of InterSystems technology, and we can get into some very interesting funky design with multi-tiers, right? And so how do you provision something like that? Very, very, very interesting architecture, and how much time do you have, and what happens when it's up and running up there? Sometimes we want to say we just want to do a quick test, and I don't want to incur any more costs, so I want to be able to provision everything. So those are the type of issue that we're looking at, and what happens is that routine really does not allow us to progress. If we keep doing the same thing that we've been doing for the last decades, we want to look at a technology, a methodology that allows us to be more efficient within our software house. And so we are facing, or we are living in the third platform era, the most dynamic, the most powerful platform era. And at the same time, we keep hearing, this digital transformation moment that is very important these days. We also say that it's the age, it's the API age, and all of this focus, all of this pressure that we feel, for our companies for being competitive. It means that we have to do more. We have to do it in a quicker way, and still the accuracy and stability has to be maintained. And so I think there are three main focus areas in IT innovation these days. So the first one is the application, the second one the infrastructure, and the third is the operational way with which we answer some of these challenges these days. So the application, of course, can be traditional. It can be all the way cloud native type of application with a DevOps methodology, breaking down the silos, using microservice architecture, maybe even, of course, with containers, continuous delivery type of processes. The infrastructure, we've seen that there's this layer of abstraction that we can utilize and be much smarter and efficient with that. But what about our operational engineer? How can we help them? How can they become more efficient? And that is one of the points, because although there are three main areas, they are all interdependent. So if we change one, a second area of this IT solution provisioning, can be really benefit. So there are definitely processes and methodology that can be adopted, that can be reviewed and implemented. There's CI/CD, continuous integration, and continuous delivery. And automation type of tools that we can look at. There's now a standard application solution package, the container. And there's also new type of architecture that we can embrace. They are very interesting, very powerful, but can also be very, very complex. And we call this really, when we start adopting and looking at this type of methodology, we are looking at rendering and morphing our application into a cloud native application. And how do I become a cloud-native application? Well, Heroku, several years ago, started by saying, we've identified some principles that if we adhere to, we can make our application as a service, and it can be quite dynamically, provision, run, and these are some of those are the 12 factors. So, for example, there's one code base, but it can be multiple implementation. Dependencies, for example, needs to be declared, and they need to be satisfied at build time. Configuration and injection as the applications, the solution starts up. Backend services, of course, we need to utilize, like backup services, etc. And then the fifth point, then the build, release, run. There's a clear distinction between the build moment, the releasing of the artifact, that solution, then the run that we're going to see a little bit more in detail. And of course, I'm going quite fast here, and every slide here would need a lot more in-depth conversation and understanding, but they're just pointers for us to understand how we've been thinking about InterSystems Cloud Manager and all the benefit and the efficiencies they can provide to us. So really, it's about modernizing what we have, modernizing all three aspects of IT innovation that we talked about. So the how we package the application, the infrastructure, how we use infrastructure these days, but also how the operational engineer are going to utilize, the tools and the methodology that can be used. And of course, if I modernize and I start by, for example, modernizing my application by putting it into a container, then it means that I can automate a lot of the steps. I don't have to keep installing the application in different environment. It's just the same artifact. And with that means that slowly I can look at transforming the way I really operate inside my software house. So let's just get a step back and have a look at a typical product delivery. I have a developer that commits some code, and then we probably have a staging area somewhere where we extrapolate that code, the classes, the routines that the developer has created, and maybe we have some pseudo static global that we need to update in production, and then of course I need to have a script somewhere, right? That unzip, untars the solution, takes that code, put it into the new the installation that I have in production, compile it, make sure that everything is okay, and I'm up and running with the new version. If on the other end you already decided to walk a slightly more modern way of looking at things, and so separating code from data, maybe you do all the operation already in a staging environment, and you freeze a cache.dat, an iris.dat, and then you deliver that, and all of a sudden you have the new application. There are many ways that a company organizes all that. The problem is when I go into do a proper build, that's a test of the building of our building application, and when I give that same code to a quality assurance department, what do they actually do? Do they test the code? I'm afraid not. The first thing they must do is they must install the application first. They must install the code. And when I go in pre-production or go to production, there's always an installation to do. Why don't we automate it? Why don't we start thinking a different way, a little bit smarter, a little bit more agile in the way of operating with our code? And so before reviewing that slide, showing a more agile way of operating, why do we look at what a modern DevOps shops identify in terms of phases in order to optimize the software factory? We have our developer there that is using Atelier or whatever other editor it might need, and it can be on Mac, Linux, Windows. And when it commits the code, it's basically finished the design development part. After that, we go into the build phase. So we do a continuous integration type of operation with tools like Jenkins and Bamboo, Travis CI, etc. And out of that build phase, we end up with an artifact. And if the artifact is good, successful, it passes our testing, there will be also a cycle of obviously quality assurance testing here. Then the developer himself or herself, can utilize the artifact. There's another phase called the release phase, which means we have a product that built okay, that passed QA, quality assurance testing, and everybody is happy and is ready for deployment. It doesn't mean that just because I release 10 times a day, I can deploy 10 times a day. That's more of a business decision. However, that same artifact then is the one that goes through the run phase, the last phase when I go into production. And as you can see and start appreciating here, these phases are very well distinct. And the first three phases run inside our software factory that we're trying to modernize. And what I notice here is that, and this is much of the value that solutions like containers provide to us. I have one single artifact. I don't have to keep installing the software throughout various machines to do quality assurance, to do pre-production testing, UAT, etc. Is the same artifact. And actually, the mere fact that this same artifact, the same container, is used all the way from left to right, from the developer all the way to pre-production, it means that by definition is going through a lot more QA than just the QA suite that we all have. And of course, also the other artifact here, when I do the run, when I go look at the run phase, is that the artifact that the container, Docker container, is actually portable, and so I can run the solution on premises and on public cloud, and it's exactly the same box, if you like. Also, this means that our operation engineers, our system administrator, if we need to change, to swap cloud providers on-prem or public, they know exactly what they're doing. It's the same. It has the same behavior. It has the same format, and so we're actually standardizing inside the software, our software house, how we work with software. And so then going back to a full CI/CD with containers, it means that I reach production parity. And some people say, what do you mean on your laptop as a developer you have 64 gigabyte global buffer? No, those variables are injected as you run, as you instantiate the solution. The reality is that although we use the same code base. And so what we see here, that as the build phase number 4.4, is built and quality assurance tested, and it passes everything. We have a Docker registry, a container registry. Container registry are part of the ecosystem of containers that we find them on premise in private data center, but also in all the public data centers. So there's a full ecosystem of technology available to us as we work with container. That's add a lot more value to everything that we're doing. So we see here in the provisioning pipeline that the containers become that build pipeline, single binary, very easy to administer, very easy to handle. That offers a lot more agility and efficiency. Yep. And there is in fact another question for you to answer. So we get some feedback, and maybe some question will pop up at the end of the presentation. Yep. So the question is, have you implemented CI/CD provisioning pipeline at your organization?
Okay, so it looks like we have about a quarter of respondents said yes, and 3/4 said no, they have not.
Okay. So what we see that with this new technology, this new container technology that is taking the cloud world by storm, we solve a lot of problems, and there's three fundamental issues that every software house has to deal with. So the first is the packaging. How do I package? Do I put everything in a tarball and an MSI, and then unzip, untar, install, and create my environment variable, my environment as I need it for my application, etc. Or you can just package everything in this container that's totally movable, portable. The second one is the distribution. As I mentioned earlier on, the whole cloud world out there is ready with container registry, repository, basically, where you can move your application, your containerized application. And the third is the execution. It's a special package. It's not an RPM. It's not a YAM. It's not an apt get install type of package that comes down. It's a package that is runnable package, and within it I can find all the necessary dependencies already satisfied, because I satisfied them at build time when everything was under my control in my software factory. And so it's a very powerful and valuable type of packaging that we have here. People that were using DevOps, this is from RightScale last year. They see basically no value in still utilize some of the configuration management tools. They're obviously very good, and they've been very useful in the past. But now we're moving forward. There's more abstraction. There's more power with this type of technology. And Gartner said, thinks that by 2020, more than 50% of global organizations will be running containers in production. Well, nobody has the crystal ball to really know, for sure about all the data that we see. Right now, all we know is that there's been 26 billion pools of containers in the world, and that's just a staggering number. And if only 1% of that were enterprise solution, it would be quite incredible. So very quickly to recap, a Docker file is a definition that allows me to define all my dependencies. Okay, so my code, maybe some jar, maybe some particular Python version that you need. From there, you really run the build process. The build process spits out an image, and this image then can be utilized anywhere I want. And as we said, there are container registry anywhere in the world that are there for us to just leverage. Benefits. I'm not gonna stay here and bore you with this. We we can all read about them. Let me just mention the last line. There's a clear distinction that's, between, and a clear separation of concern between code and data. Containers are good for really encapsulating my code and make it movable and portable, and the data, of course, needs to be mounted on host volumes. And the other thing the container pushes to think about is the separation of concern between the build process in a DevOps pipeline and the run process. I don't do installation again. I don't look after my pet, my expensive pet, and spend hours, days to configure it. I already have configured everything at home. And of course, InterSystems IRIS data platform now is also supplied as a container for you. We run lots of security check in the container. We set it up as small as possible, following all the best practices that we could. And some of the benefit here that we see is, for example, we created IRIS main as the main process. The main process means that it means if I just do a docker run IRIS, that's the typical docker command, the container will come up, the write daemon, the garbage collector, all our journal daemon will come up, and then it will just go down, because they're not the processes that they are designed to hold up a container, to hold up an operating system, if you like. So we built IRIS main, which is the main process that we find inside a container. Is PID1, process ID 1, and that holds it up for us so that we can start up InterSystems IRIS. But it does a lot more. During the life cycle of a container, it starts up, it's PID1, IRIS main, but it also, we made it flexible so that you can interject some of those events. So, for example, before InterSystems IRIS starts, then you might want to do something. Then we start InterSystems IRIS, and after InterSystems IRIS is up, maybe you want to set a few other variables or a few other things in your environment. And then, of course, the other thing that we do is we listen for interrupts. So if somebody issue a docker stop command, we just run an orderly shutdown so that our database are completely clean. And I'm going to go very quickly here, but fundamentally InterSystems IRIS is a first-class citizen, because we're able to persist at the host level the durable, the percent sys, InterSystems system database, and we call this feature the durable sys. And of course, you'll have to do exactly the same for your database, because we don't want to store data inside a container. A container is just code. It's typically treated as a real ephemeral type of solution. And so what we have is that if I want to come around tomorrow with version 2 of my application, what I simply do is I stop my container and I start my container with my new hot smoking version of the application, and all I have to do again, mount those volume again. So it's very, very quick and efficient. And how does durable sys works? Well, very simply, we follow the standard that we find with Docker. So we know we can pass environment variables. So -e, we have an IC data directory. We tell it's a flag that tells us that we want to clone %sys from inside the container to an outside host volume. And also, of course, we have to have that host volume -v, fast, reliable file system, mounted column inside the container as /iris, and that's where we will find the %sys mounted. So what happened is, as we start, we see that flag, that variable, I see data directory, and as we start the container, we clone it at the host level. And what happened then is that if I come along with version 2 of my application, we run exactly the same command, of course, and so we say how he wants to clone the durable sys. We go and check it. Effectively, it does exist, so I'm going to mount that one. And if InterSystems IRIS has a new version, then we just run an upgrade, and it's completely transparent, just like you would do it on any normal host. So, InterSystems Cloud Manager is working and is being thought in terms of providing abstractions, as we've seen, and operational agility. And we are leveraging containers because they give us a lot of agility, a lot of benefit, and a lot of efficiency back home in our software factory where we're tinkering all this technology. And before I go ahead, I'm going to switch to my terminal to start some operation for InterSystems IRIS, because we're going to provision a couple of clouds, and it takes a few minutes. So let's start, and then I'll come back and talk to and explain my slides. So I'm going to go back to, okay. And what I'm doing here is I'm running a shell script that instantiate a container, an ICM container. Okay, I'm inside the container, and there's a directory that just mounted this S3, which has some information. I'm going to do the same on this other screen, if you can see. Just because when you work with the cloud, sometimes things work, sometimes don't. So I'm actually going to provision on the screen on the left on AWS, the screen on the right on Google Compute Platform. And I'm going to my directory, got my file, and I've just got a key generator here. Okay. So I'm generating some SSH key, I'm generating some TLS certificate, and I'm also grabbing some InterSystems IRIS key that we're going to utilize to provision our infrastructure in the cloud. So the next thing I'm going to do, let's open this guy here. Okay, I'm going to change some of the label. I'm going to come back and explain this. So this is a webinar online, let's call it WO. And today is the 17th, and this, let's do run 2 today. Let's save that. That's okay. I'm going to come back to explain all this, but before I do that, I just wanted to connect to the AWS portal to show you that we don't have anything here. So I'm going to the EC2 instances. There are none running. Let me open the actual portal so you don't see any instance here. And the GCP should be around here. I just have a virtual machine, a compute node there. I'm doing some testing, but we're going to see several other there's. Okay. So because it's going to take a few minutes, let me run the command. So it's ICM provision. I'm going to explain all this in a second. I'm going to do time so you see these things. Okay. Oh, there's no, okay, no IRIS found. Yep, no InterSystems IRIS key found. Okay, I think I know the problem. Give me a second. I was set up on a wrong network. So let's do this, ICM provision. Okay, starting to provision. And time here, ICM provision. It usually takes 4 or 5 minutes. And in the meantime, we go back to our slides. We're going to explain what we've been doing. So the idea, fundamental idea, as you see on the screen, is they want to give you the capacity to define, create any cloud, and deploy anywhere, and of course run it on demand. So let's go into the details. So InterSystems Cloud Manager is an infrastructure provisioning and deployment tool. It allows me to provision a cloud infrastructure. So all the details that we saw on the AWS slide, for example, okay, the virtual private cloud, the data center that they want to define, basically our data center in a public cloud, the compute node, how to tune the compute node, the type of storage, the type of network, everything. You can do it with InterSystems Cloud Manager. It doesn't only do provisioning, it does a deployment. What does that mean? It means that we instantiate the InterSystems IRIS service, and not only that, we don't stop there. We don't have to go back to configuration management tool. We configure ECP, we configure the shard workers, and mirror if you wanted to, and arbiter and web gateway. We just do all the hard work that is necessary for all of us to do. We want to offer that with InterSystems Cloud Manager. So again, we are working at a very high abstraction level, which is in line with what's happening out there in the industry, and we want to offer a lot of agility with it. So the software abstraction, the software-defined infrastructure that we utilize, that we are as InterSystems Cloud Manager, allows us then to work in private cloud on premises, okay, where you have typically hyper-converged infrastructure or simple VM even. We can actually call vSphere low-level API and create a virtual machine. And of course, even if it's only version 1 of this tool, we support already the top 3 public cloud provider: AWS, Google Compute Platform, and Microsoft Azure. And as you see there, we are able to define exactly the compute node, the storage, networking, and other details, the load balancers, etc. A lot of organization, of enterprise organization, okay, will need a multi-cloud strategy. There's no doubt about it. And even if we sign a contract today, I fall in love with Google. They got fantastic networking, but tomorrow, maybe some of the pricing structure they have might not be as cool. So maybe I move to Microsoft Azure, or vice versa, or maybe I want to try, some other utilities, some other services, with AWS. So how do you do that? How do you deal with that? And that's why InterSystems Cloud Managers is cloud agnostic. We support straight away, as I said, AWS, Google Compute Platform, and Azure straight away in version 1. But we cannot forget our customers that work on-premise, on private data centers. So we support VMware vSphere. We are able to define directly a compute node there, and also what we call pre-existing. Pre-existing could be, well, either a virtual machine or a bare metal machine, and we can configure InterSystems IRIS data platform right in there. As long as there's an IP address and SSH connectivity, we can do that. So a question could be, tell me more about this InterSystems Cloud Manager. What's the software stack? What does it look like? Well, first of all, you don't have to install anything. Second, you don't have to configure anything. All you have to do is just run this package. It's called a container, and it's very light, and you can run it from literally any machine because containers are portable, we said, and everything is already configured for you. So let's go and have a look. What do we have inside the container? So inside the container we find there's Terraform, a very popular, famous infrastructure as code open source solution that is specialized in calling the low-level API of all the various cloud providers. We wrap that up with the Java wrapping, so that we can leverage multi-threading and be even faster as we go out to the cloud and do operations. And we offer you a command line interface. Command line interface that you see me using. You already see me launch the program. That in our mind it will be used in a programmatic way. And we're already here, even at InterSystems, our quality development department, when they do all their testing, they launch more than 25 different cloud configuration every night to test our software. And that's pretty cool. And they do everything with this tool. And of course, the last point here is that the abstraction level that we offer you is a simple JSON definition. So we go back to InterSystems IRIS data platform, a possible architecture solution where we have a multi-tier architecture. How do you configure all that? How do you do that? How can we support all this? Because this looks a lot more complex than a traditional, application server, ECP, and a centralized database server. It is indeed. You offer a lot more to InterSystems IRIS. And yes, InterSystems IRIS Cloud Manager allows us to configure all those multi-tier type of cloud solution that we can have through simple roles, tags, and label fundamentally. And so we know that shard data master is identified as DM for or DS for a shard data worker, etc. And we see also that we have specialized roles that actually translate in specialized container for us, like the arbiter, the web gateway, mirror configuration. If you want mirror configuration, all you have to do is just switch a boolean from off to on, and we configure mirror for you. So it's very, very powerful. And these are the JSON definition that you saw me very quickly edit before. So we have two of them, just to make it a little bit easier, hopefully. One is called the default, that typically deals with the definition of the cloud provider. And so in this example, for example, I've got AWS. I've got some labels here. In fact, I could even switch to a real one that they've used. Okay, so on AWS, I want to create my cluster in AWS. I'm defining some labels. I got some tags. The OS volume I want it to be 10 gig. The data volume is the same. I need to define the region, the zone, the floor within the data center, if you like. We want to use a particular Red Hat AMI. In this instance, a particular instance type to give us a particular number of cores and memory. Of course, I need my credential to access these resources, right? The SSH user that will be used to access that particular EC2 instance in this case. I have keys for the SSH keys, the TLS certificate, the Docker version that I want to install that will provision for you. The particular Docker InterSystems IRIS image that I want to pull, so there's no copying tarball file, and zipping, untarring, installing. It's just pulling, running it straight away. And then you might be familiar with some of this. So this is what type of system mode is a development system, is a production system, and some of the socket that you probably recognize, the InterSystems sockets. The password, okay, I can set a password for all the cluster nodes that I have out there, and then namespace. It means that the Cloud Manager goes off and create a database or namespace that will be sharded for me automatically. And also I wanted a mirror here. In the definition JSON, instead, what I see is that I have only a two-layer architecture here, just to be quick, because I said yes, for example, to mirroring, that I want to account of 2 for data shard master servers. I tell him where to go and get the license. I also want to configure a little bit different from the default value, because this is the master shard server, and I want to have 4,000 megabyte of global buffer, routine buffers, and some particular other information. Also note, please, how I specify a different data volume size versus the widget file. We're trying to use, of course, and follow our own best practices, and so these are actually definition of mounted specific volumes that are dedicated to those files. So that's very powerful. Let's go back to our provisioning. And what we see here, for example, is that they finished, and I'm just gonna run ICM run. That's on Google, and let's do the same for AWS. And of course, I need my password. Okay, is the password for a private repository where I have my images, I have my application, so I'm pulling those containers from a particular registry. And while that run, I can just show you what it looks like if I do a refresh in this AWS standard AWS portal, where I see there's some of the labels and the tag that they've used. I said in a webinar online, so it's WO, and I can see that I have compute nodes provisioned for us, and because we said that we want a mirroring, I have 2 DM, 2 data shard masters, and the same goes for data shard servers. So I believe we defined 6, so there'll be only 3 shard servers, but they are configured in a mirror configuration, the systems mirroring technology. And if I go and have a look at the volume, there will be a series of volume according to what we defined that we wanted. So journal 1, journal 2, widget, the database, etc. Okay, and so that's AWS. Let's have a look at Google GCP, Google Compute Platform. That's what it looks like. So this is just the portal of the providers. Very good. While we're waiting for the configuration, let's go back to our slides. Okay, so just to recap, two simple JSON definition is our level abstraction for everything. And the affinity or the placement strategy that we use when we deploy containers, as we're using containers, is a very simple one. It's the last one on the bottom right-hand side, is a distinct instances. Why is that? Yes, we could put more than one container in one compute node, but what is the point? Because our application is a database, right? What we have is a database, so we want to leverage all the resources of those common node type that we find in the cloud. So I want to use 100% of those CPU. I want to use 100% of that memory that's available for us for buffer caching. And also this means that any management is very, very easy, because it's just like having installed a standard InterSystems IRIS manually. And so this way we can manage, we can see every node, and we can address any issue that might be on any instance, on any service that is up and running. But how do we speak? How do we put in communication containers that reside in different nodes? Well, there is an overlay network. We're using the weave.works. There is exactly this operation. It's a professional product, it's an enterprise product, but they also have an entry level that does exactly what we need. And if interested, you can go up the layers and create a lot more of flexibility and view of what's happening inside your cluster. Weaveworks allows us to put the container communication, therefore to have communication between the InterSystems IRIS clusters, so ECP networking, cluster communication, etc. And yes, the WeWork is part of the fairly new Cloud Native Computing Foundation, where we'll see that even AWS decided to join last year, and this organization should ensure that we have standard and we're able to all work in a more resilient way in the cloud. When the provisioning of the infrastructure was finished, I ran a second command. It was just ICM run, which means instantiate all the services and configure them, so that we have our cluster that we defined. But it doesn't finish there. InterSystems Cloud Manager allows us also to connect directly to the compute node. Okay, we have the SSH keys already there, right? I can also jump directly inside the container if I ever need to do anything. I mean, ideally, you should have done everything when you were doing the build phase that we talked about in the provisioning pipeline of your software factory. And the other powerful thing that we can do is we can connect directly into InterSystems IRIS with the ICM session. That allows us to go into the instance itself, and if you need to set a global node, if you to run a class method or whatever that may be, maybe create a new index, and you haven't got time to provision a new container, you can do that. So you can configure the default cluster configuration that we provide you exactly as you want. So as a summary, then we're going to have a look at the software again, see if it's all configured and it's up and running for us. We have a software-defined infrastructure or infrastructure as code type of tool that allows us to have and to think in a really abstract way about a cluster configuration in the cloud, on-premise, we said, and in public clouds. It's cloud agnostic, so very quickly, but just by changing the provider, I can utilize and I can test on the public cloud provider. And it allows us to enter into a more modern provisioning pipeline by utilizing two technology, the containers, and then this high-level abstraction and low-level API the public cloud allows us to talk to. We offer a simple command line interface. I'm going to run a few extra commands down for you, so you have an appreciation of how it behaves. And you don't have, the other point is you don't have to install anything. You don't have to configure anything. It's just provided to you as a very simple, small container. So let's go and have a look at what's happening at ICM level. Okay. Let me open, for example, this one. This is the Amazon provisioning. Okay, and we can try to connect there. Okay. So I'm on Amazon on the West Coast here. I could, for example, have a look at system operation, make sure that the mirror is really set up properly, and I can also set up these things here. Check them here. I can do ICM inventory, for example. Oops, if I can spell inventory. And I see that I have two data shard master that configure in a cluster configuration. The one with the plus is telling me is the primary. If I go back to my portal, I can see here that there is a master 0 is the primary, and there's a master 0 and is a 002, the node 002. Which is exactly what my inventory told me. Okay, so I'm configured in a mirror situation, in a mirror configuration, and I can see that both of them are using the arbiter, so I'm very happy with that. In fact, I can see here the arbiter node. Other thing that we can do is we can check, for example, the data shards. I'm going to look at the ECP settings. And I see that I've got 3 shards, although we said in the configuration that we want 6. But because we said yes to mirroring and they hold data, then we configure them automatically for you as a mirror pair. So I have 3 shards available to me here. Yeah. Okay. In the meantime, they reminded me that there is time for a third questionnaire for you. Is your application cloud native or at least cloud friendly? Just to check they followed the presentation.
All right, it looks like we got about half people saying yes, my app is cloud friendly. About 20% saying yes, my app is cloud native.
Cool, fantastic, excellent news. Thank you, guys. That's very good. So hopefully, looking at InterSystems Cloud Manager, gives you a more trust in what we're doing, and maybe one day you can even leverage it.
We have some questions coming in. Just time for a couple quick questions.
Mm-hmm.
One was whether HealthShare and Ensemble supports this, or do they need to be running IRIS?
Right now, InterSystems Cloud Manager has been developed and thought only for InterSystems IRIS. However, we have some customers that I'm aware of. They are running Cache and Ensemble in containers, and with a couple of minor workaround, we could make you can make InterSystems Cloud Manager to work with your containers. Yes.
Okay, then one other question was whether ICM can help assist with multi-tenancy, actually helping customers run multiple instances either on one instance or multiple containers.
Right now, the focus has been on InterSystems IRIS data platform, just because you've seen a couple of those slides where we have multi-tiers, and therefore the configuration, we can spend hours on the cloud, on portals, try to configure everything, and on SSH connectivity. So we really wanted to make sure that InterSystems IRIS had a really easy, nice, quick, intuitive experience where developers and people can put data in there and start using the analytics part of the power of InterSystems IRIS. I think there can be announcements. I think this is only the first version, please remember. To me, is just an MVP, a minimal viable product, although quite cool for the feature that it has. If you consider that we already support the three major cloud providers, and we want to expand those in the private data centers. So there's a lot of work that we want to do. Yeah, that's all I can say right now. And we have plans and projects that are already running with more features. Any more questions?
That's all the questions that we have online.
Okay. I was thinking showing a couple of commands, but literally I can just show them because I think we're running out of time, so I don't want to waste your time, guys. So thank you for being online. But just running ICM, it tells me that I can provision and unprovision. So I'm going to start the unprovisioning now because I don't want to spend any more money on these two clouds. Inventory just gives me a list of what's being provided. I can SSH directly into the compute node. I can run specific Docker command. I can pull new image. I can start and stop those containers. Let me just give you very quickly like a PS for process status, container, IRIS. So it picks up only the IRIS container, so I can see they're all up and running. The status is up, and that's really cool. And let's just do ICM. If I do inventory again, just very quickly, just to show you what if I wanted to connect. I need to be able to spell. What if I wanted to connect to a particular node directly into an IRIS session and maybe do something there, right? So I can do ICM session interactive namespace DB, and I think that's. Oh no, I need to tell the machine, of course, dash machine, and let's go on the master here. Okay, so I'm connected all the way on the West Coast in AWS with the password that I defined, and here I am inside that session. I can see that go my 4,000 megabyte global buffer as we defined because it's a shard master. Other things that I can do quickly, I can do, for example, ICM SSH. On all the node, I want to know how much space there is for those disks, for example. So how about this? SSH-command, and I do a df like that. And because I'm not specifying dash command. What's wrong with that? Oh, am I misspelling it? Command. I was. Sorry. So it's run this df command on all of them, and I want to make sure that I still have space, for example, on my DM node. So I'm just going to do that. And as you can see, the directive of a 40 gig for my data database versus the 20 gig each for each journal, etc., is being respected. So those EBS those block storage devices were configured exactly as we said. So I think with this we are basically well over the time. Sorry, we stole more of your time. It's about them building, deploying, be able to manage. That's another way of looking at InterSystems Cloud Manager. Further information can be found on these links on our community developer community. Thank you very much for listening. I hope that has been useful to everybody. Thank you.